Okay, hello guys. So today we're going to look into partial fractions. So let's have a look into example 1. So in this example 1, we try to express this algebraic fraction into partial fractions, okay? So normally in exams, what you have might not be expressed as the linear factors in the denominator. Instead, you might have a fractions given like 7x plus 8 over x square minus 2x minus 24. So as you can see now, in example 1, I already factor the denominator into linear factors for you. So in terms of exam is concerned, as far as exam is concerned, whenever you have algebraic fractions, so first of all, look into the denominator and see whether you can factor into linear factors or not. So that is what you should do. Okay, always express the denominator as a linear factors. Okay, so let's have a look into this form. Okay, so now if you realize, if you notice that the numerator, the power of x, so the terms in x, for example 7x there, so it's just a linear. Okay, and also the denominator is actually, if you expand that, you're going to have a x square, so it looks like a x on top and x square in the bottom. As you can see, because the numerator has less power compared to denominator, so this is a proper. Okay, we can consider this as proper algebraic fraction, if you want to say. So that means, if you have these situations and denominator is now expressed in linear factors, so what you should do now is transform this into uh, the algebraic form, partial fraction form. So for this type of case, when you have the power of x on numerator and the power of denominator of x in denominator is much more compared to the numerator, so and the denominator can be expressed as linear factors, so you want to write down is identical to a constant x plus 4 plus b over x minus 6. Okay, please look at this two fraction there. If you look at it, you might want to ask me why you put a and b on top. So to make it simple, so I just explain in a way that if your denominator is a linear, so your numerator should be a constant. So as you can see, since this is a linear, so the numerator must be a constant. Okay, so we'll see later on how numerator will change when the denominator is not a linear. So if we go back to this form, so what you do next is just like doing normal addition on fractions, so you make the denominators the same. So if you do that, what you have is 7x plus 8, x plus 4, x minus 6 identical to or equivalent to a over x plus 4. Then I multiply by x minus 6 over x minus 6. Okay, and for this term b over x minus 6, I will multiply this by x plus 4. So it's also the same as what we normally do when we want to add two fractions. Okay, now in practical, you don't have to write that. Okay, so I did that for the purpose of illustrating how it works. So normally in most of the cases, I will straight away write down at 7x plus 8 is identical to or equivalent to x minus 6 plus b bracket x plus 4. Okay, as you can see now, I start to ignore the denominators, because now the denominator is the same, because you can see that this one and this one is going to be the same as this one. So that's why I ignore this denominator here. Instead of that, I just consider the numerator instead. Okay, alright. So now what we do next, so our purpose is to find what is a and b. So to do that, what you do first, you set, okay, we say let x equals to 6. What is the reason? Because I noticed that if I put x equals to 6 there, that means this whole term going to be 0, then the whole thing will be 0. If the whole thing will be 0, then I'll just left with b multiplied by some value here, and this is just a number here. So I have just a linear equation with one unknown that I can find my b. So let's do that. Let's see what happened. Alright, okay, so if you do that, you can see that this one is going to be 7 times 6 plus 8 equals to 0 plus 10b. Okay, alright, so now this is 4250, I believe. 42, yeah. So this is 10b. So b is now 5. Okay, so again, let x equals to -4. So what I have here is 7 -4 plus 8, which is equivalent to -10a plus 0, because you can see that when s is equal to -4, I will have 0 there. So this is -28, so it's going to be -20 there. So I have -10a here, so therefore a is equivalent to 2. So now we have seen that we have managed to get the two unknown a and b. So I'm going to rewrite, so we can express this algebraic fraction 7x plus 8 as x plus 4 x minus 6 equal to 2 over x plus 4 plus 5 over x minus 6, which is, you can verify that if you expand, if you add these two algebraic fraction there by cross multiply. So you can see that I have 2x minus 6 here plus 5 times x plus 4 over x plus 4 and x minus 6 here. Okay, so if you expand that, you're going to have 2x minus 12 plus 5x plus 20 over x plus 4 x minus 6. So this is going to be 7x plus 8 over x plus 4 x minus 6. There you go. So that means we have managed to re-express this algebraic fraction into a partial fraction. Okay, so remember again, first of all, make sure you factor the denominator into a linear factor first as possible. If not possible, or if not irreducible, then we'll see in the next types and so on. So once you have done that, you take each of the linear factor here you put into a bracket. So what happen if you have three brackets, for example? If you have three brackets, so immediately you will say that this is a over the first bracket, so this is the first plus b over the second, okay, this is the second, so this is the third, so you have c over the third one. So that's how it works for linear factors in the denominator, provided the power of x, the highest power of x on the top must be less than the combination of this whole bracket if you expand. So just make sure it is a proper algebraic fraction, linear factors in the denominator, then you can express as that, then you proceed as normal as I show you on the top there. Just combine them, then substitute x according to what is the bracket, what you have in the bracket there, then eventually you will have your a, b and c. So I hope this explain the first example. I'm going to stop now and continue the video for type 2 in the next video. So good luck.